Okay, so in this video I'm doing some slightly more difficult naming alkanes where we have branches involved. So let me start immediately. Okay, so again, the way we would start if we wanted to name this one is to find our longest carbon chain. It really does not matter which route you take as long as you have single bonds between carbons and there's no carbon there's no branching in your chain. Okay, so if I start here, I can have 4 here, or if I go in this direction, I can have 4 there. So it doesn't really matter where I go. I'm just going to choose the simplest route. Then I need to number. I can see here is my alkyl branch. Okay, it's my alkyl branch. I need to start numbering on the side where this one is the closest. So this would be 1, 2, 3, 4. As soon as I've done that, I can get started with naming. Because it has 4 carbons in it, I know this is butane because they have single bonds between the carbons. Now I need to name the alkyl group. The alkyl group is on the second carbon, so this would be 2, and then the alkyl group in this case is a single carbon in that branch, making it a methyl. Remember, meth, F, and let's just go to prop for now. Okay, this is a methyl. Oh, actually, let's go to bute since we're working with butane. Okay, so the fourth one, when I've got a single one, it's meth. Since it's a branch, it's an IL. If it was part of the main chain, it is ane, but this is methyl. 2, and there should be a dash between 2-methyl butane. Okay. Actually, let's start by doing the condensed structural formula for this one as well. The condensed structural formula goes to every carbon and describe every carbon in the main chain, let me say that, and describe what bonds does it have. This carbon has 3 hydrogen bonds, the first one. The second carbon has a single hydrogen, and then it has a branch to it. So remember, branches we put in brackets. So CH in this, we will describe this whole thing. You'll see some more examples here. So we will describe the whole branch in the same way. So there's a single carbon that has 3 hydrogens. Then the branch is done. So we close it. The next carbon has 2 hydrogens bonded to it, 1, 2, and then it's bonded to another carbon which has 3 hydrogens bonded to it. 3 hydrogens. Let's count to write the condensed, the molecular formula. 1, 2, 3, 4, 5 carbons. 5 carbons. Hydrogens 3, 4, 7, 8 plus 3 is, oh, did I miss one? Yes, I didn't put 2 here. Okay, the second last carbon has 2 hydrogens. I'm sorry. Okay, but I noticed that because I know that the general formula must be for all alkanes, whether they have branches or not, should be for every carbon there must be double as many hydrogens plus 2. So I know if there's 5 carbons, I must have a total of 5 times 2 plus 2, which is 12 hydrogens. Okay, and so I picked up my arrow. Cool, so use that. Okay, this one, whoa. This one looks intense. What on earth is happening here? Especially all of a sudden, instead of doing this for the 3 hydrogens, okay, it's just putting it as it would have in the condensed structural formula, which I'm sure you can figure out that's what they're doing. It's not that difficult. So my first carbon, instead of doing my 3 bonds like that, we're just writing it as CH3. Okay, so that's this carbon. So let's see, where would we find our longest carbon chain? So we've got 1, 2, 3, 4. When I get here, I've got an option. I can either go in this direction and count, or in that direction and count. So I've got 1, 2, 3, 4, 5, 6 if I go this first route, but you'll notice the next route will take me further. 1, 2, 3, 4. Now instead of going up, I'm going on. 5, 6, 7. This is my longest chain. Now they did it on purpose like this so that it looks like this part here is a branch. Okay, a branch isn't simply when the structure changes direction. A branch has to be a split, and you can see here this carbon he still has 2 hydrogens, which means his other 2 bonds are with carbon. Okay, which means there is not a split at this point. Okay, so we've got 7. 7 is hept. Okay, so we'll have bute, pent, hex, and pent. Sorry, hept. Hept. Okay, so this is heptane. The name is heptane. Okay, and we see this heptane has a branch. Now we need to number so that this branch has the smallest number. So I can either number 1, 2, 3, 4, or I can number from this side 1, 2, 3, 4. It doesn't make a difference from which side I'm numbering. It's always the 4th carbon that has the carbon chain. So this will be a 4. And now I need to describe my carbon chain with a name. There's 2 carbons in this chain, which make it an ethyl. So this is 4-ethyl heptane. Okay, there's nothing else to describe here. And now for my condensed structural formula. Okay, again, it didn't matter from which side I number, but obviously I would always start with number 1. Okay, so let's just go from this side. Would be exactly the same. Now my first carbon is CH3, my next CH2, my next one CH2, but in the 4th one, 1, 2, 3, 4, the 4th one is just CH. It's got a single hydrogen. Okay, then it has a branch. In my branch, okay, it would be CH3 plus CH2. Doesn't really matter which way you write it. CH3, CH2. Okay, I suggest write it in the order that you would have encountered it. So let's write it in this order: CH2, CH3, because that's the next carbon, is CH2. That's the one that's directly bonded to the CH, and then a CH3. Okay, and then this one's slightly longer. Then we go on to our next carbon, which is carbon bonded to 2 hydrogens, and then bonded to another carbon who's bonded to 2 hydrogens, and then our last carbon is bonded to 3 hydrogens. Okay, so since this carbon has 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in total, we know using this formula we should have 20 hydrogens. Let's check ourselves. 3 and 2 is 5, 6, 7, 8, 9, 10, plus 3 is 13, plus 2 is 15, plus 2 is 17, plus 3 is 20. Excellent. This is C9H20, my molecular formula. Okay, now let's go to this one. This one has a combination of what we've seen so far between the 2 different ways of writing our structural formulas. Okay, here we can see they've sometimes shown us the hydrogen bonded, or they've just used the condensed structural method of writing it for some of them. Okay, especially for the branches, they like doing that. Okay, so if we were to number this, if we were to name this, we first need to find our longest carbon chain. We can start here, 1 carbon chain going from here up. That would give me 3 carbons. Or I can go on, okay, and then up. That would give me 4. 1, 2, 3, 4 carbons. That's the longest chain I can find. But I could have also gone down here. Look, there's another carbon down here. So 1, 2, 3, 4. Doesn't matter as long as you find the longest one. So 1, 2, 3, 4 means I'm working with a butane. Okay, 4 is bute. Okay, now I need to number so that my chain is on the first thing I encounter. Okay, so now you can see if I were to take this carbon chain, it's probably a good idea just to show myself which carbon chain I'm using. I can start from here, then I've got 1, 2. My second carbon will have a carbon chain, or I can go from here, 1, 2. My second carbon again will have another carbon chain. So again I see, well, it doesn't matter from where I number, so let's just choose any one of the 2. I'll just choose a reading direction 1, 2, 3, 4. Those are my carbons. Okay, I notice that I've got, in my chains, I've got, and that's what I do now, is I identify the types of chains that I have. Okay, I've got 2 methyl chains. You can see both chains only have a single carbon in them, which make them methyl groups. So I've got methyl, okay, but I've got 2 of them, so I have to put a die in front to tell my reader I have 2 methyls, and then I just need to show them where those 2 methyls are. Both of them could have been on 2. This could have been 2, 2 if this group was just down here, but it's not. The second one is on the 3rd carbon, so this is 2, 3 dimethyl butane. Okay, so without looking at my structural formula, let's see if we can use our condensed structural, our name to write the condensed structural formula. Okay, how will we do that? Okay, first of all, we will start with a carbon. Obviously, all of these start with a carbon, and for alkanes, the first carbon will always have 3 hydrogens. Now I go to my second carbon, which will always have 2 hydrogens unless I have a group. Okay, because if I've got branches, then it's likely that instead of having 2 hydrogens, one of the hydrogens could have been replaced with a group, and that's exactly what we see here. It's replaced with a methyl. Okay, so this one has only 1, so he's got 2 places. He could have taken 2 groups, but he only got 1, okay, which means that the other one is still a hydrogen, and then we had a group. The group was a methyl, which we know is just CH3. It's 1 carbon, and that carbon has 1 of its bonds with this carbon, and the other 3 carbons have hydrogens to it. Okay, then we go to our next carbon. Again, this second carbon has 2 bonds, because it's not the last carbon, which has 3 available bonds. Okay, and it could both have been groups or methyl branches, but it's not. Only one of them is. So only one of them is a methyl branch, which means that the other one must be a hydrogen and then a methyl branch. Like that. Excellent. And then I see I've got 1, 2. My main chain is obviously the butane. So obviously all the carbons that's not in brackets. So it's 1, 2, 3. I have 1 left, and obviously the last one must also have a hydrogen, 3 hydrogen bonds, because it's butane. Then let's quickly check ourselves. Do we have 1, 2, 3, 4, 5, 6 carbons in total, which means I need a total of 14 hydrogens. Okay, let's test ourselves. 3 plus 1 is 4, plus 3 is 7, plus 1 is 8, plus 3 is 11, plus another 3 is 14. I've done it correctly. Okay, I actually had a lot of fun naming this and giving you the insight into how to get the name, the condensed structural formula, as well as the molecular formula, and using all of that to check yourself. I hope you learned something, and that you will get the hang of it pretty soon. Good luck.